Okay, so here's the puzzle that was in the New York Times. And this is a very challenging puzzle. But the reason I wanted to talk about it with you is because it's a modular arithmetic puzzle. A chess master is practicing for a tournament. She plays at least one game every day, but no more than 12 in any 7 days. So she doesn't go crazy and play like 100 games in a day or something like that. In fact, in any 7-day period, she never plays more than 12 games. Okay?
Yep.
But she plays at least one every day. And the question, the challenge puzzle, was prove that if she continues this practice long enough, that there will be some set of consecutive days in which she plays exactly 20 games. Whoa, what? What? How's that going to work? So let's start at the beginning. Can you just list out some numbers of games she might play on some days?
Well, she might play 2 games one day. She might just play 1 day again. She might play 3, and then she might do a lot and might do like 7.
Oh, okay. So interesting. Let's take a look at that. Might there be a day where she plays 7 games? Now remember, she doesn't play more than 12 in any 7-day period.
Well, but we don't know how. Well, if there's 7, if she can't. Well, we could find what she can't have more than have in 1 day.
Oh, okay. What would be the most she could have in 1 day? That's a good question to ask.
Well, she can't have 7
Why not?
because there's 7 days in a week, and she can't play more than 12 in any week. But if she plays 7, she has 5 more games. She's 5 more games she can play.
Yeah.
And she has to play at least 1 game a day.
Very, very good observation. If she plays 7 one day, she's got 1, 2, 3, 4, 5, 6 buckets left, right?
Yeah.
And so, but the total from here to here can't be more than 12?
Yeah.
But there's got to be 1 in every bucket at least, right? So what's it going to be?
So it has to be 6.
And if she does play 6 games on 1 day,
She can't play 6 on another.
she can't play 6 anytime soon. What are the rest of the days going to have to be for a while? All 1s. Okay. So that's interesting. So she can't play 7 ever. So we just learned that.
Yeah.
Okay. But she could do 2, 1, 1, 3, and then maybe continue on like 1, 1, 1, 1, 2, maybe 3, 1, 1, 2, 1, 1, 1 like that.
Yeah.
Okay.
Well, maybe we could try to find the modular arithmetic in here.
Well, yeah, we'll get to that in a second. So, how would we find consecutive days in which she plays exactly 20 games? What are we going to do about that? We need to kind of add up the games. You want to do that?
Yeah.
So let's see if in our example here, we just made these numbers up, right? Does she ever play exactly 20?
Well, in like a week?
No, in some number of days. Could be a long stretch of days. In fact, I'll continue this. 2, 1, 1, 3, 2, 4. Oop, can't do 2, 4. 1, 1. All right, let's see.
Well,
Why don't you just add them up and see if we ever get to 20?
2 plus 1 is 3, and 4, 5, 8, 9, 10, 11, 12, 13, 17, 18, 19, 21.
Oh, 21. We never played. Okay. 21,
And then
22,
20,
23,
24, 26,
26.
27, 28, 31, 33, 34, 35. We never added up to 20.
Yeah, and it didn't say it had to be right from the start,
No.
but by just kind of luck, because we just made these numbers up,
Yeah.
we never got to exactly 20. So what can we do?
Well,
And let's move on to part C.
here.
Okay, just to make the movie not super long each time.